Hi everyone, welcome to this workshop. Today we practice on Cramer's rule. So we have, with the grammar rules, we have the formula x equal to dx divided by d and y equal to dy by d, dy divided by d, and we also have z equal to dz divided by d. But right now, so far we deal with system of two equations, two variables, so we just have x and y. We will talk about z when we get into system 3 by 3. Okay, so to solve the system by determinant, we need to know two following steps. So first, we remove the number from the determinant we're solving for and replace them with the number from column D. So first of all, we have to do is what I call outline. We bring down all the number from the determinant. So we have from the system. So you have 4, -2, -3, 5, and then we have 6, 4, which comes straight from the system. Then the first column, we get this from x, so I call this one as dx. The second column is come from y, so I call it dy. And the last one is come from constant, which I call is d, column d. So as we say, remove the number from the determinant we're solving for. Let's say if I solve for determinant d, so here my determinant d, I will remove the column d. Since we say that replace them with the number from column D, we're gonna remove D. We don't have anything to replace for D. That's it. So whatever left is our answer. We remove D. So we have 4, -2, -3, and 5. Okay. So we just finished to set up the determinant D. The next one we're gonna do is solve determinant dx. So again, determinant dx, we're gonna do is remove the number from column dx and replace them with the number from column D. So what I'm gonna do next is replace the column D in place of the dx. So we will start with 6 and 4 instead of 4 and -2. So first of all, we bring down all the numbers. So we have 4, -2, -3, and +5. You bring down the sign with the number as well. And the dash line stands for the equal and 6, 4. Okay, so we have the first column come from x, which I will call this one is my dx. And the second column come from y, so this one will be dy. And the last one come from d, which I will call d. So now let's solve the determinant d. Okay, so we have determinant d. First we're gonna do is remove the number from the determinant we're solving for. So I'm gonna remove this one and replace that number by the number from column D. Since we cross D out, we don't have any number to replace in. So what left is my answer will be 4, -2, -3, and then +5. Okay, so that is the determinant D. Now we're gonna solve for determinant dx. So I will keep the solving part for determinant D later on when we set up all the determinant of d, dx, and dy. So dx, as we say which one we solve for, we will remove that number. So I'm solving for dx, I remove this number. Then step 2, replace them by the number from column D. So I will replace all the number from column D to the dx place. So we will start with 6, 4. And since this one remove is also cancel out because you bring it into the front. So we will have determinant dx is 6, 4, and -3, 5. 6, 4, negative 3, 5. Now to set the determinant for dy, we do exactly the same things. Does my dy equal to? So we cross the column dy. Then we'll replace that column by column d. So that will be 6 and 4 at the column dy. So this is gone. So we will have 4, negative 2, 6, 4 as the determinant for dy. So 4, negative 2, and 6, 4 for the determinant dy. So we know how to set up the determinant for d, dx, and dy. Now let's jump in and solve each of them. So as we practice for determinant 2 by 2 before, we multiply cross all the way down. So 4 times 5 give me 20. And we multiply up, negative 2 times negative 3 is positive 6. Then we will have bottom subtract top, so 20 minus 6, which will give me 14 as the answer for determinant D. Okay. Now we do the same for the rest. So 6 times 5 give me 30, and 4 times negative 3 give me negative 12. Then we will have bottom subtract top, so 30 minus negative 12 minus negative 12. So negative times negative is positive. Then we will have 30 plus 12, which will give me 42. Okay, and next one, 4 times 4 give me 16. Negative 2 times 6 will give me negative 12. Then again bottom subtract top, so 6 minus negative 12. So what will give me negative is positive. So 16 plus 12, which will give me 28. Okay. After we have determinant d, dx, and dy, now we apply the Cramer rule. So we have that x equal to dx divided by d. So my dx is 42, and determinant d is 14. So we plug this in, which give me 42 over 14. So 14 go to 42 is 3 times, and now we apply for the y formula for y. So y equal to dy divided by d, dy divided by d. So dy we solved it already with 28, and determinant d is 14. So 28 over 14, which will give me positive 2. So the answer is almost done. It's not done yet. So we have 3 and 2. You have to write your answer in x and y order. So it would be 3, 2 with the parenthesis as a point. So, and here's my answer. So I believe we have some idea about solving the system of linear equations by Cramer's rule, but since the concept is quite long, so I think we should go over one more example so you will understand better. I still keep the formula on the top, and also the step, the basic way to do it. Remove the number, and you can read the rest. Now let's go over example 2. So we have 7x equal to 8 minus 4y. In example 1, we see that to able to solve this by Cramer's rule, you need x and y stay on one side of the equal and then make the outline. So we need to do the same thing. I need to move this y to the other side. So I'm gonna do is add 4y on both sides. Add 4y on both sides. That will give me 7x plus 4y equal to 8. Okay. At the second equation, we have 2y equal to 3 minus 7 half x. Right now we have fraction, so my first priority is get rid of fraction. So the LCD of this one is 2 because we have one denominator with a 2. So what we're going to do is multiply the whole equation or every single term by 2. The goal is cancel out the bottom. This 2 and this 1 will be canceled out. Then we have 4y equal to 3 minus 7x. Okay. So at the first equation, we already stay in the general form, so we good in that one. But in the second one, x and y still stay on both sides. So I'm gonna move x to the other side by add 7x on both sides to bring x over. So we will have 7x plus 4y equals to 8 and 7x plus 4y equal to 3. So now we're done they both equation in the general form, so I can go ahead set up my determinant. So first bring down or we don't have space to bring down, so I'm going to write on the side. We bring over all the coefficients, so we have 7, 4, 4, and dash line stand for equal, a and 3. Okay, as we know, this first column comes from x, so the x, dy, and d. Okay, now we set the determinant d. Let's say determinant d. So d equal to, okay, which one we solve for, we're going to cross that out and replace that by column d. Since d be cancelled out, so whatever left is my answer, 7, 7, 4, 4. 7, 7, 4, 4. Okay. Now let's do dy. Let's see this one. Okay. My bad. Let's do the x. Now let's solve for the x. So we're gonna do is dx. Let's solve for the x. So the x equal to, we're gonna do is cross out the column dx and replace that column by d. So we replace this by d, so we have 8 and 3. So we will start with 8, 3, and 4, 4. So we have 8, 3, and 4, 4. Now let's set up the dy. So dy equal to, we do the same thing, cross out dy, then replace that by d. So we will have 7, 7, and then 8, 3. So we have 7, 7, and 8, 3. So dy equal to 7, 7, 8, 3. So we have all three determinants. Let's go ahead solve for each of them. So 7 times 4 is 28. 7 times 4, another 28. And bottom subtract top. 28, which give me 0. Okay, and we have with dx, we have 8 times 4 is 32, and we have 3 times 4 is 12, and bottom subtract top, 32 minus 12 minus 12, which give me 20. With dy as well, so 7 times 3 give me 21, 7 times 8 give me 56. 21 minus 56 minus 56 will give me let's say negative 535. So we have all three determinants. Let's apply the formula. So we have x equal to dx divided by d and y equal to dy divided by d. Then we will have 20 over 0, and negative 35 over 0, which will give me undefined. And undefined. So let's make it clear here. So if you have d equal to 0, dx dy is not equal to 0, then the problem is no solution. The answer for this one is no solution. What happens if d equal to 0, dx equal to 0, and dy equal to 0? So then let's say if just only d equal to 0, then there's no solution. If d equal to dx equal to dy, they all equal to 0. Let me see. If this case happens, then we have infinite many solution. Infinitely many solution. So here is the two extra notes you need to write down. So if d equal to dx equal to dy equal to 0, then the system is dependent. So as I say, if d equal to dx, d equal to dy equal to 0 is infinite many solution, then the system is dependent. And if d not equal to 0 and dx or dy not equal to 0, the system is inconsistent or no solution for this case, and inconsistent for the system, which means they two lines they won't cross to each other. So make sure you write this one down and highlight it somewhere. It's really important note. And the next part is the cell check. Okay, I have two cell checks for you, so please working on it. If you get stuck, go back to example. You have 5 seconds to pause this one, or you will see the answer. So I believe we all have the answer. So this is my answer for problem 1. The answer is -2 and -3. And for problem 2, the answer would be dependent. Now let's go over each of them and then see why you don't get the answer if you don't. Now let's go over problem 1 together. So first step, bring down all the coefficients. So we have 3, 2, -1, 1, -3, -7. So we have the first one is come from x, so the x, dy, and then d. So determinant for column D, we're gonna drop column D or remove this number. Whatever left is my answer. 3, 2, -1, 1. My determinant dx. So I'm gonna do is cross out the x and replace it by d. Replace that by d. So you have -3, -7 is the first column. Then we have -3, -7, -1, 1. Now we have dy equal to, we cross out the dy and replace by d. So basically whatever I have right now is my determinant dy. So we have 3, 2, -3, -7. Now let's solve each of them. So 3 times 1 give me 3. 2 times -1 give me -2. Then we have bottom subtract top. So 3 minus minus 2, this negative times negative will give me positive instead. So 3 plus 2 will give me equal to 5. On this one, we have negative 3 times 1 is negative 3. Negative 7 times negative 1 is positive 7. Then bottom subtract top. So we have negative 3 minus 7 will give me negative 10. And also on this, so we have negative 21, negative 6, then negative 21 minus minus 6 will give me negative 21 plus 6 give me negative 15. Then we apply the Cramer's rule. We have x equal to dx divided by d. Then we have dx is negative 10 and d is 5. So negative 10 divided by 5 give me negative 2. And y equal to dy divided by d. And dy is negative 15. Divided by d is 5, so we have negative 3. Then final answer is x and you have to write your final answer in x and y order. So we have negative 2 and negative 3 is the final answer. Now let's go over problem 2. So we have two equations with fraction. So to get rid of the fraction in the first one, we will multiply both sides by 5. Multiply both sides by 5 so that we can cross out the bottom. That will give me 5x equal to 12 minus 6y and to cross out the bottom on problem 2, so you multiply both sides by 12, then this 12 will be cancelled out, which will give me 12y equal to 24 minus 10x. Then we also need x and y stay on one side. So I'm going to do is add 6y on both sides for the first equation. So we will have 5x plus 6y equal to 12. And I also move 10x on the second equation to the other side. So plus 10x on both sides. Then we have 10x plus 12y equal to 24. What I'm going to do next is copy the coefficient, bring it over. So 5, 10, 6, 12, and 12 and 24. So we have first column come from x, so dx, dy, and then d. Now let's set up determinant d. D equal to, we cross out the column D, so you will have 5, 10, 6, 12. I'm gonna set up determinant dx, so we cross out the dx column and replace it by d, so you will have 12, 24, and 6, 12. 12, 24, and 6, 12. So we have 12, 24, and 6, 12. Next one is dy. dy will be equal to, so I cross dy and replace by d. But it's still we will have 5, 10, and 12, 24 is the determinant for dy. 5, 10, and 12, 24. Now let's go ahead solve each of them. 5 times 12 give me 60, and 10 times 6 give me 60. 60 minus 60 give me 0. 12 times 12 give me 144, and 24 times 6 also give me 144. So 144 minus 144 give me 0 again. So last one, dy, if dy different from 0, since d is 0, if dy different from 0 or the x different from 0, I can say no solution. But if dy is also a 0, then we will say is infinite many solution. So 5 times 24 will give me 120, and 10 times 12 give me 120 as well. 120 minus 120 give me 0. Since d equals to dx equals to dy equal to 0, then my answer will be infinitely many solution. And it also can say that the system is dependent. The system is dependent. Extra practice. I have 4 problems for you to work on. If you get stuck, go back to the examples and the cell check to make sure you understand the concept. So you have 5 seconds to pause this video and try on this. Good luck and hope you get correct answer. Now I hope that we have the answer. Here's the following is my answer. Alright, that is my answer. For problem 1, you have 3 and -1. Problem 2 is no solution, or the system is inconsistent. Problem 3, -5 and -8. Problem 4, the answer is infinite many solutions. And also can be called as the system is dependent. So hope that we get correct answer, and thank you for watching.